A colossal stone block, weighing more than a small house, sits perfectly locked in place without a single drop of glue. This video explores 30 ancient engineering marvels that defy logical explanation. And by the end, you will see the timeline of human history, not as a straight line, but as a story filled with mysterious peaks and forgotten valleys. How did cultures without cranes or computers move mountains of stone? And what secret understandings of the world did they possess that we have since misplaced? What does it say about us that the most enduring monuments on Earth were built with methods we still cannot fully replicate? Are we truly the pinnacle of progress, or just one chapter in a much longer book of human ingenuity? These structures stand as a silent challenge across the millennia. To understand what makes them truly inexplicable, we must first step into a world of profound absence. It is a world without power tools, without steel, without the mathematical notations we take for granted. Yet from this world, civilizations produced monuments that have outlasted empires and withstood the relentless test of time. So what exactly qualifies as an ancient engineering marvel that defies logical explanation? It is not merely something that was difficult to build. The pyramids were difficult. What we are looking for are achievements that exhibit a sophisticated understanding of principles we would not expect them to know, executed with a precision we struggle to achieve even with modern technology. Archaeologists, from mainstream academics to independent researchers like Graham Hancock, often debate the how, but they can agree on the staggering what. The criteria become clear when we look for a few key markers. The first is inexplicable precision. We are talking about stone blocks cut so perfectly that a razor blade cannot slide between them, astronomical alignments accurate to a fraction of a degree, and foundations level across miles of uneven terrain. The second is monumental scale and logistics. Imagine coordinating thousands of workers to move a single stone weighing over 1,000 tons across rivers and up mountains, using only ropes, wood, and human strength. The third is material science. How did they shape granite, one of the hardest stones on Earth, with what appear to be simple copper tools? And finally, longevity. These are not ruins in the sense of decay. They are structures that have actively resisted collapse for thousands of years, their original builders' secrets locked within their flawless joints. This is the crucial difference between a project that was hard and one that seems, from our current historical perspective, nearly impossible. It hints at a lost chapter of knowledge, perhaps passed down through meticulous oral tradition and apprenticeship, a blend of artistry, astronomy, and physics that we are only beginning to decode. With this foundation of mystery laid, we can begin our journey to the sites themselves, starting with one of the most iconic and debated wonders in human history. Rising from the Giza Plateau is a structure so familiar its strangeness has been worn smooth by time. The Great Pyramid of Khufu is the sole survivor of the original Seven Wonders, a title that undersells its reality. This is not merely an old tomb. It is a mountain of precision-engineered stone, a monument that has whispered its secrets in a language of mathematics and astronomy for 4,500 years. Its scale is the first shock, 2.3 million blocks averaging 2.5 tons each, a mass so vast it can be seen from space. But the true mystery is not in its weight, it is in its flawless execution. The pyramid's base is level to within less than an inch across its entire 13-acre footprint. Its four sides are aligned to the cardinal points with an error of just a fraction of a degree, a feat requiring an understanding of true north that seems impossible for its era without advanced tools. Then there is the mathematics encoded in its very shape. The ratio of its perimeter to its height is remarkably close to 2 times pi. The dimensions of its inner chambers and passages reflect sophisticated geometric principles, including the golden ratio, a proportion celebrated in nature and art millennia later. This is not random. This is deliberate, intelligent design etched in limestone and granite. The precision extends to the smallest details. The pyramid was once sheathed in highly polished, white Tura limestone casing stones. These were cut with such exacting angles and fitted so seamlessly that, from a distance, the entire structure would have appeared as a single, gleaming geometric form. Even the interior, often thought of as simple chambers, reveals staggering complexity. The king's chamber is built from immense blocks of red granite, a material harder than steel, quarried from a swan over 500 miles away. How they transported these 80-ton monoliths and raised them to such a height remains one of archaeology's great puzzles. The chamber itself is capped by 5 gigantic granite ceiling slabs, each weighing over 50 tons, arranged to distribute the pyramid's colossal weight away from the room below. This is structural engineering of the highest order. Furthermore, narrow shafts, once thought to be air vents, extend from the king's and queen's chambers and point directly to specific stars like Orion's belt and Sirius, stars of deep religious significance. This suggests the pyramid was not just a physical structure but a celestial map, a machine connecting the earthly and the divine. The debate over how it was built has raged for centuries. The traditional theory involves vast ramps of earth and brick spiraling up the pyramid's sides, yet engineers have struggled to make this model work. The ramps would have required more material than the pyramid itself, and their construction and removal present logistical nightmares, especially for achieving the final, exquisite precision of the apex. This gap between the proposed methods and the achieved result has led researchers like engineer Christopher Dunn to propose a radical idea. What if the Great Pyramid was not just a tomb but a functional machine? He and others point to its unique acoustics, its geometric proportions, and the strange, tool-marked stones in its subterranean chambers as evidence of a lost technological purpose, perhaps related to energy or vibration. While mainstream archaeology firmly holds to the tomb theory, the machine hypothesis forces a vital question. Does our modern assumption that ancient people were primitive blind us to the possibility of a different kind of sophistication? Were they using a blend of knowledge, from astronomy to resonant frequency, that we have since forgotten? The Great Pyramid stands as our benchmark, a perfect fusion of scale, precision, and mystery. It tells us that our ancestors were not just building monuments. They were encoding knowledge into the landscape, crafting puzzles in stone meant to endure long after their spoken language faded. If this level of inexplicable genius existed in Egypt, what other wonders were being conceived simultaneously on distant continents? While Egypt's pyramids reach for the heavens, another mystery lies shattered across a high desert plain in Bolivia. The site of Puma Punku, part of the larger Tiwanaku complex, sits at an altitude of nearly 13,000 feet, a place of thin air and relentless wind. What remains here is not a towering, intact monument, but a field of architectural chaos. Enormous stone blocks, some weighing well over 100 tons, are scattered like a giant's discarded toys, many fractured as if by unimaginable force. The first impression is one of pure destruction, a city of the gods struck down in an instant. But look closer at any one of these fallen stones, and the true, deeper mystery begins to unfold. These are not crude rocks. They are masterpieces of precision engineering carved from andesite, a stone as hard as granite, with a finesse that defies the accepted history of the Andes. The most iconic are the so-called H-blocks, named for their distinctive shape. Each is a geometric puzzle, featuring a series of identical, perfectly spaced notches cut with absolute right angles and uniform depth. When viewed side by side, these notches are so consistent they appear to have been made by a single, giant cookie cutter, not by teams of artisans wielding handheld tools over years. The surfaces of these stones are flawlessly smooth, flat to a degree that suggests grinding or polishing by machine. Even more baffling are the intricate channels and dovetail cuts found on other slabs. These are not decorative, they are complex interlocking joints designed to fit together with other stones using a principle akin to modern seismic construction, allowing movement without collapse. Researcher Brian Forrester has extensively documented these features, pointing to drill holes that are perfectly cylindrical and grooves with sharp, clean internal corners that are notoriously difficult to produce even with today's diamond-tipped tools, as they require a tool that can cut perfectly into a 90-degree angle. How could a culture believed to have had only stone hammers and copper chisels achieve this? One compelling theory moves beyond carving altogether. Some geologists and alternative researchers propose that the builders of Puma Punku might have used a form of lost knowledge involving stone softening or even a type of vitrification. The idea suggests they could have chemically treated the andesite to make it temporarily malleable like clay, allowing them to mold these precise shapes before the material rehardened. While controversial and without definitive proof, this theory attempts to bridge the gap between the artifact and the presumed tools. The logistical mystery is equally profound. The andesite was quarried from a site over 50 miles away, across mountainous terrain and beside Lake Titicaca. Transporting these multi-ton blocks without the wheel, without draft animals stronger than the llama, presents a puzzle that echoes the pyramids. Did they use a now-forgotten system of canals and rafts? Did they possess a knowledge of friction reduction we cannot replicate? Puma Punku does not give easy answers. It presents a field of exquisite questions. It challenges the linear timeline of human progress, suggesting a peak of technological ability in the distant past that was followed not by advancement, but by a profound forgetting. What cataclysm, whether natural or social, could shatter such a place and scatter its sophisticated knowledge to the winds? The stones themselves hold the only clues, silent and precise, waiting in the high-altitude sun. From the shattered stones of Puma Punku, our journey leaps from solid earth to the sunken treasures of the Aegean Sea. In the year 1901, sponge divers off the coast of a small Greek island called Antikythera made a startling discovery amidst the wreckage of a Roman cargo ship. Among statues and pottery, they recovered a corroded, lumpy object of bronze and wood about the size of a large book. It was set aside as a curiosity, its true nature hidden under centuries of marine incrustation. Decades would pass before anyone realized that this unassuming artifact was, in fact, the most sophisticated scientific instrument to survive from the ancient world. We now know it as the Antikythera Mechanism. This was not a statue or a weapon. It was a machine. Through painstaking analysis using advanced imaging techniques, researchers like historian Tony Freeth have pieced together its incredible function. The mechanism was a hand-powered, geared calculator designed to model the cosmos. By turning a crank on its side, an operator could advance a complex clockwork of at least 30 interlocking bronze gears, which in turn moved delicate pointers across several dials on the front and back. These dials displayed the positions of the sun and moon, predicted lunar and solar eclipses, and even tracked the cycles of the known planets. One of its most remarkable features was a dial that followed the 4-year cycle of the ancient Olympic Games. But the true stroke of genius lies in a specific component buried within its corroded heart, the differential gear. This is a brilliant piece of engineering that allows two rotational speeds to be averaged together. In the modern era, we find differential gears in every automobile, allowing wheels to turn at different speeds around a corner. Prior to the discovery of the Antikythera mechanism, the earliest known example of such a gear was from the 16th century, a gap of over 1,500 years. Its presence in this 2,000-year-old device is nothing short of revolutionary. It tells us that the mechanical imagination of the Hellenistic Greeks reached a zenith we never fully appreciated. This was not a toy, it was a precise mathematical instrument encoding advanced astronomical knowledge. One dial accurately modeled the Metonic cycle, a period of 19 years after which the phases of the moon repeat on the same dates. Another accounted for the elliptical orbit of the moon, a subtle irregularity that requires sophisticated gearing to simulate. The implications are profound. The Antikythera Mechanism was not a one-of-a-kind miracle. Its very existence implies a tradition, a school of thought and craftsmanship dedicated to creating such devices. The historian Cicero wrote of a similar instrument brought to Rome, suggesting this knowledge, while rare, was known among the intellectual elite. So what happened to this brilliant lineage? OF Chinese letter, Chinese letter, Chinese letter, Chinese letter. The secret may lie in the shipwreck itself. The vessel was a Roman cargo ship, likely looting treasures from the Greek world. The mechanism's journey to the seafloor may symbolize a larger historical truth. With the decline of the Hellenistic world and the rise of Rome, a focus on pure science and complex engineering may have faded, preserved only in fragments and cryptic texts. This single device forces a complete recalibration of our historical timeline. It proves that concepts we associate with the Renaissance or the Industrial Revolution were not just dreamed of, but were physically constructed in antiquity. It stands as a silent, ticking rebuttal to the idea of linear, constant progress, whispering that genius can flare brightly, only to be submerged by the tides of time, waiting centuries to be recovered and understood. High on a mountainside overlooking the ancient Inca capital of Cusco, a fortress of stone defies both invaders and explanation. Sacsayhuamán is not built from uniform bricks, but from a colossal jigsaw puzzle where every piece is a boulder. The walls rise in dramatic, zigzagging tiers, constructed from massive blocks of limestone, some weighing well over 100 tons. The sheer scale is intimidating, but the true genius reveals itself upon closer inspection. Each stone is an irregular polygon, a unique shape with multiple sides and angles. Yet these giants fit together with such breathtaking precision that the seams between them are virtually invisible. It is often said that not even a razor blade can slip into the joints. This is not simple stacking. This is a master class in polygonal masonry, where every block was painstakingly carved to interlock perfectly with its neighbors on all sides, creating a monolithic wall without a single drop of mortar. The purpose of this incredible precision goes beyond aesthetics. Peru rests in a highly active seismic zone, a land frequently shaken by powerful earthquakes. The polygonal design is a feat of ancient engineering specifically for seismic resilience. When the ground trembles, a rigid wall of straight lines is prone to cracking and collapse. But a wall built like Sacsayhuamán, with its interlocking, irregular blocks, allows for minute shifts and movements. The stones actually settle tighter together during a tremor, redistributing the energy throughout the structure. It is a dynamic, living wall that dances with the earth rather than fighting it, a principle modern engineers strive to emulate. This reveals a profound, practical understanding of their environment, encoded directly into the stone. But how was it done? The quarries for this distinctive limestone are located miles away across rugged valleys. The Inca did not use the wheel, nor did they have draft animals capable of pulling such loads. The transportation alone is a logistical puzzle that fuels countless theories. Some researchers point to sophisticated systems of ropes, ramps, and manpower, a coordinated effort of thousands. Yet the legends passed down through generations speak of something more mystical. Stories tell of a lost knowledge, where the stones were made to move to the sound of specific frequencies or chants, a concept often referred to as sonic levitation. While mainstream archaeology views this as myth, it underscores a central truth. The achieved result feels so miraculous that it inspires explanations beyond the conventional toolkit. The physical shaping of the stone presents another deep mystery. How did workers using stone hammers and bronze tools achieve such flawless fits on these enormous, irregular blocks? Some researchers, like those who study Puma Punku, have suggested the possibility of a plant-based chemical agent that could temporarily soften the stone's surface, allowing for precise shaping and polishing. While no direct evidence has been found at Sacsayhuamán, the theory persists because it attempts to answer a very simple question. How do you achieve machine shop precision on a mountaintop with pre-industrial tools? The walls themselves offer few clues, their surfaces smooth and their joints silent. Beyond the Great Walls, other features deepen the mystery. Integrated into the design are curious, smooth channels cut into the rock, often called slides. Their function is unknown. Were they part of a ceremonial system, perhaps for channeling water or other liquids during rituals, or did they serve a more practical construction purpose, helping to guide or position the massive blocks? Their presence reminds us that our understanding of this site is incomplete. We see a fortress, a place of formidable defense with its zigzag angles designed to trap and expose attackers. But it was clearly more. Inca scholars note it was also a ceremonial center, a place where the celestial and the terrestrial met. This dual purpose reflects the Inca worldview, where engineering and spirituality were not separate disciplines, but intertwined expressions of a harmonious order. Sacsayhuamán stands as a monumental testament to a forgotten dialogue between human ingenuity and the natural world. It is architecture as adaptation, a conversation with stone and earthquake written across a mountainside. The fortress does not merely resist time. It engages with the very forces that destroy lesser structures, using a language of interlocking angles we can still see but cannot fully speak. It proves that resilience can be built not through brute force, but through intelligent, patient collaboration with the materials and challenges at hand. If such wisdom could be locked into a fortress, what other profound understandings were woven into the fabric of their daily lives, now lost to us? Our search for these lost arts leads us from the heights of Peru to a city of towers rising from a desert floor, where the challenge was not moving stone but creating life from dust. 2,000 miles from the nearest continent, a silent council of stone giants keeps watch over an empty landscape. Easter Island, or Rapa Nui, is one of the most isolated places on Earth, a speck of volcanic rock in the vast Pacific. Yet here, a society with no metal tools, no wheels, and no large animals produced nearly 900 monumental statues, the Moai, each a solemn, towering figure gazing inland from coastal platforms called Ahu. The largest of these figures, named El Gigant, lies unfinished in the quarry, a colossus that would have stood 70 feet tall and weighed an estimated 82 tons. The scale is staggering, but the true, haunting mystery lies in the journey. The quarry at Ronoroku, a volcanic crater, is where the Moai were carved directly from the soft volcanic tuff. From this single source, completed statues were somehow transported miles across the island's rugged, hilly terrain to their final coastal perches. How did a few thousand people move multi-ton blocks of stone across such a distance? For decades, the dominant theory was one of sheer, grinding effort. It was believed the Rapa Nui people cut down the island's once lush palm forests to create networks of logs, rolling the statues on wooden rails. This narrative became a cautionary tale about ecological collapse, a society so obsessed with monument building that it deforested its own home, leading to cultural decline. But recent archaeological work, led by researchers like Terry Hunt and Carl Lipo, has turned this story on its head. Their experiments suggest a far more ingenious and dynamic method. They propose the Moai were not dragged but walked. The key lies in the statue's distinctive design. Many moai have a pronounced forward-leaning center of mass and a rounded, convex base. By attaching ropes to the statue's head and base, a skilled team could rock the giant from side to side, edging it forward with each rhythmic tilt. In a famous experiment, just 18 people, using 3 sturdy ropes, were able to maneuver a full-scale concrete replica several hundred meters in this fashion. The statue seemed to come alive, swaying and progressing in a controlled, upright walk. This walking theory elegantly solves several puzzles. It explains why so many statues are found along ancient roads in a fallen, but upright, position they toppled during transport. It also aligns with local oral traditions that speak of the statues walking to their ahu, guided by the spiritual power or mana of chiefs and priests. This was not mere brute force logistics. It was a coordinated, ritualized act of engineering, blending physics with ceremony. The societal effort was still immense. Carving a single moai with stone hand picks or toki took a team of skilled craftsmen perhaps a year or more. Transporting it required the coordinated labor of entire clans, a communal endeavor that reinforced social bonds and honored ancestors. This leads to the statue's profound purpose. Contrary to popular belief, the moai are not facing the sea to watch for invaders. They face inland, watching over the villages and farmlands of their descendants. They are considered the living faces of deified ancestors, their immense presence a conduit of spiritual power and protection for the community. The later addition of the pukao, the giant cylindrical top-knots made of red scoria stone, added another layer of complexity. These stones, some weighing over 10 tons, were quarried from a different volcano and placed atop the moai on the ahu. Their transport and lifting, likely up earthen ramps, represents a second, breathtaking phase of engineering. The environmental story is also being rewritten. While deforestation did occur, evidence now suggests it was a gradual process exacerbated by the arrival of invasive rats, not solely by a frenzy of statue moving. The island's story is one of remarkable adaptation and resilience, not just collapse. The moai of Easter Island stand as the ultimate testament to human ambition in isolation. They prove that innovation is not dependent on outside contact or abundant resources. It can spring from a deep cultural need, from a desire to connect with the past and secure the future, carved and walked into existence against all odds. They challenge our most basic assumption that remote means primitive. Instead, they show that when faced with a monumental vision, human creativity finds a way, even if that way is a slow, rhythmic walk across a lonely island. This same spirit of connecting earth and sky through immense effort can be found in a different form, not in the Pacific, but in the heart of Cambodia, where towers rise from the jungle like stone mountains. Deep within the Bekaa Valley of Lebanon, the ruins of a great Roman temple complex command the landscape. Yet the true wonder of Baalbek is not the elegant columns of Jupiter that rise toward the sky, but the silent, staggering foundation upon which they stand. This platform is built from stones of such impossible scale that they seem to belong to the realm of myth. Here, perfectly fitted into the western wall, are 3 behemoths known as the trilithon. Each is a worked block of limestone measuring roughly 64 feet long, 14 feet high, and 13 feet deep. Their weight is estimated at 800 to 1,000 tons each. To grasp that scale, imagine moving 3 fully loaded jumbo jets, using only ropes, wood, and human hands. The Romans built their magnificent temple atop this base, but they did not create these foundation stones. They found them already there, a gift from a forgotten age, and they used them because moving such monoliths was beyond even their formidable engineering capabilities. This presents a profound, layered mystery. Who were the original builders, and what colossal structure were they intending to create long before Rome was even a kingdom? The precision of the stones deepens the puzzle. The blocks are cut with clean, sharp edges and fitted together with tight, mortarless joints. Archaeologists who study the site openly acknowledge that the technical achievement represented by the trilithon is unparalleled in the ancient world. The logistical challenge begins at the quarry, located nearly a mile away from the temple complex. There, still attached to the bedrock, lies an even more massive stone, known as the Stone of the Pregnant Woman. This abandoned monolith is estimated to weigh over 1,200 tons, making it the largest known worked stone on the planet. The fact that it was partially cut free demonstrates an intention to move it, a thought that staggers the modern mind. How could any ancient society conceive of quarrying, shaping, and transporting a single object heavier than a naval destroyer? The methods proposed only highlight the gap in our understanding. Some theories suggest the use of vitrified tracks, where a layer of sand or another material could be heated to create a glass-like, low-friction surface to slide the stones. Others point to legends from the site itself, which speak of a time when the stones were moved by sound or by command, stories that echo those from Sacsayhuamán and Puma Punku. While these may be metaphorical, they underscore a universal human response to witnessing the impossible. We reach for explanations that transcend the ordinary toolkit. The alignment of the site adds another dimension. The entire complex is oriented with significant astronomical precision, suggesting its original purpose, like so many of these marvels, was tied to the heavens, perhaps as a ceremonial center or observatory of immense importance. Baalbek stands as a monumental palimpsest, a later civilization writing its story over the faded text of a far older, far more powerful one. It forces a humbling question. If a culture could move mountains of stone with such apparent ease, what else did they know about the world that has since been erased from history? The foundation is a message in stone, a signature of giants from a lost epoch of mega-engineering, waiting for us to decipher its meaning. From this platform of giants, our search for lost connections leads us across the ocean, to a desert where lines were drawn on such a scale they can only be seen from the sky. A desert floor becomes a canvas visible only from the heavens. In the arid plains of southern Peru, the Nazca Lines transform a seemingly empty landscape into one of the world's most enigmatic art galleries. From ground level, you see only faint trails, worn paths across reddish pebbles, but ascend into the sky and a breathtaking panorama unfolds. Colossal geometric shapes, perfect triangles and trapezoids stretching for miles, share the earth with intricate depictions of a hummingbird, a spider, a monkey, and even a figure many call the astronaut. These are not paintings, they are geoglyphs created by the ancient Nazca people between 500 BCE and 500 CE through a deceptively simple, yet monumentally scaled engineering process. The method itself is a study in elegant efficiency. The Nazca desert crust is covered with a layer of dark, oxidized pebbles. Beneath lies a lighter, sandy subsoil. To create a line, the builders meticulously removed the top layer of stones along a predetermined path, piling them carefully to the sides to form a contrasting border. This exposed the bright earth beneath, creating a stark, clean line that has endured for over 2,000 years. The engineering marvel is not in the digging, but in the execution. The straight lines run for miles across uneven, rolling terrain without deviating. How did they maintain such perfect linearity over hills and valleys without a high vantage point to guide them? The answer lies in sophisticated, low-tech surveying. Researchers like Maria Reich, a German mathematician who devoted her life to studying the lines, proposed that the Nazca used a system of stakes and cords. By setting a central line of sight using a series of aligned posts, they could extend a straight path by simply keeping two distant markers in line. For curves and complex figures, they likely scaled up small, master designs using a grid system, transferring the design point by point to the vast desert floor. This required not only geometric understanding but also immense communal coordination, with teams working on different sections of a single figure they would never see in its entirety. This leads to the profound and persistent question of purpose. Why create art that you can never fully see? Maria Reich became a passionate advocate for the astronomical calendar theory. She meticulously documented how many of the long lines point directly to the rising or setting sun during the solstices, and how certain animal figures may correspond to constellations important to the Nazca. The spider, for instance, is argued by some to be a representation of the constellation Orion. These alignments suggest the geoglyphs functioned as a giant celestial calendar, marking seasonal changes critical for agriculture in a harsh environment. Other theories view the lines as sacred pathways. In this interpretation, the figures and lines were not meant to be seen from above, but to be walked upon during rituals. Individuals or processions would move along the shapes, perhaps as a form of pilgrimage or to commune with deities associated with water and fertility, the most precious resources in the desert. The straight lines could have served as processional routes connecting ceremonial spaces. The most speculative idea proposes the lines were messages or offerings to gods in the sky. This theory imagines the Nazca creating these immense works solely for divine eyes, a permanent prayer etched into the earth to plead for life-giving rain. The truth may be a combination of all these purposes, blending astronomy, religion, and social ceremony into a single landscape of meaning. The precision of specific figures deepens the wonder. The hummingbird's long, slender beak is rendered with a single, unbroken line. The spider, a figure nearly 150 feet long, includes an accurate depiction of a reproductive organ found only on a rare species of spider native to the Amazon rainforest, hinting at knowledge from distant ecosystems. The so-called astronaut, a large figure with round eyes, stands on a hillside, its meaning utterly lost to time. The endurance of the lines is another silent testament to the builder's skill. The region's unique microclimate, with minimal rain and almost no wind, has preserved these fragile scrapings in the earth for millennia. The Nazca understood their environment intimately, choosing the perfect canvas and technique for a legacy meant to last. The Nazca Lines stand as a monumental paradox. They are a feat of precise, large-scale engineering executed with simple tools, a communal project for a vision only fully comprehensible from a perspective the builders could never physically achieve. They challenge our very definition of art and purpose, proving that human ambition can extend beyond the limits of individual perception to create something meant for the cosmos itself. This act of aligning Earth with sky through immense, coordinated effort finds a strange echo in another part of the world, where an entire city was designed as a perfect reflection of the heavens. Beneath the sun-baked fairy chimneys of Cappadocia lies a world turned inside out. While other civilizations built towers to reach the heavens, the people here performed a different kind of miracle, carving downwards to create a sanctuary in the earth itself. The Derinkuyu underground city is not a cave or a simple shelter. It is a subterranean metropolis, an 18-level labyrinth descending nearly 200 feet into the soft, volcanic tuff rock, engineered to sustain an entire community of up to 20,000 people for months at a time. This is not a place of mere survival, but of sophisticated, planned living. The scale alone is disorienting. Imagine an inverted apartment complex with streets, rooms, storage chambers, wine presses, and even chapels, all meticulously hollowed out from solid stone. The engineering challenge was immense and multifaceted. First, the builders needed an expert understanding of geology. They had to identify stable rock layers, map out support pillars to prevent collapse, and design a layout that maximized space and structural integrity across multiple stacked levels. This was not random digging. This was architectural planning in 3 dimensions, executed in darkness with hand tools. Then came the life support systems, the true markers of advanced engineering. Deep wells, some plunging over 170 feet, tapped into the groundwater table, providing a secure, internal water source that could not be poisoned or cut off from above. A network of over 50 ventilation shafts, some as narrow as 4 inches wide, brought fresh air circulating to the deepest chambers, while also cleverly disguising the city's presence from the surface. These shafts were engineered with precise angles and placements to ensure consistent airflow and maintain a stable, cool temperature year-round, a natural form of climate control. Historians note this complex was used from as early as the 8th century before the Common Era, with various civilizations from Phrygians to early Christians expanding and inhabiting it over centuries. Its longevity speaks to a generational project, a cumulative work of underground civil engineering. The city's design reveals a society organized for resilience. There were separate areas for livestock with designated stables on the upper levels. Communal kitchens featured intricate ventilation to channel smoke away. Large circular stone doors weighing up to a ton could be rolled across key passageways from the inside, sealing entire sections in moments. These were not just barriers. They were sophisticated security checkpoints, controlling movement and isolating threats. Perhaps most astonishing is the discovery that Derinkuyu is not alone. It connects via a miles-long tunnel to another massive underground city at Göbekli, suggesting a hidden network of refuges beneath the entire region. This implies a level of regional cooperation and long-term strategic planning that rewrites our understanding of ancient community defense. The social organization required to build, maintain, and govern such a space is a marvel in itself. It speaks of a highly disciplined communal society with specialized roles, from engineers and diggers to water managers and security coordinators. Derinkuyu defies every simplistic notion of primitive cave dwelling. This was a calculated choice for safety, a deliberate creation of a parallel world below. It represents a pinnacle of underground civil engineering, where the mastery of ventilation, hydrology, and structural mechanics ensured not just temporary hiding, but the preservation of an entire way of life through generations of conflict. It asks us to reconsider where we look for the pinnacles of ancient innovation, not always up at soaring monuments, but sometimes down into the cool, dark, ingeniously crafted heart of the earth. The 20th century presents a mystery that feels both modern and ancient, a testament to one man's obsession with stone. In the sweltering heat of Florida in the early 1920s, a frail Latvian immigrant named Edward Ģgantija began a solitary project that would baffle engineers for decades. With no witnesses and only the most basic tools, he single-handedly quarried, carved, and erected over 1,100 tons of oolitic limestone, creating the enigmatic complex known as Coral Castle. The structures themselves are astonishing: a 9-ton gate that pivots perfectly on a metal rod, balanced so exquisitely that a child can push it open with a single finger. A 22-ton obelisk towers beside a crescent-shaped moon block weighing 23 tons, all aligned with celestial precision. Ģgantija, standing just 5 feet tall and weighing barely 100 pounds, claimed to have rediscovered the building secrets of the ancient Egyptians and the pyramid builders. He worked almost exclusively at night, shrouding his methods in secrecy. Neighbors reported hearing him sing to the stones, and he spoke cryptically of understanding the laws of magnetism and weight. He insisted he knew how the Egyptians had built the pyramids, stating it was not done with brute force, but with a profound understanding of natural forces. How did he achieve this? The tools he left behind were rudimentary: a collection of homemade tripods, chains, and metal stakes. There were no cranes, no heavy machinery. no evidence of the massive ramps or crews required for such work by conventional understanding. This gap between his physical capacity and his monumental output fuels endless speculation. One compelling theory suggests he mastered a form of acoustic or electromagnetic levitation. Ġgantija himself wrote pamphlets about magnetic currents, and some researchers propose he could have found a way to counteract or dramatically reduce the weight of the stones using vibrational frequencies or clever manipulation of the Earth's magnetic field. Others believe he was a mechanical savant who secretly devised simple but brilliant leverage systems, using fulcrums, counterweights, and block and tackle arrangements that he dismantled and hid after each use. He may have reverse-engineered the principles behind ancient megalithic construction, applying a lone inventor's mind to problems solved millennia ago by forgotten cultures. The precision is as baffling as the scale. The famous revolving gate, carved from a single piece of stone, was so perfectly balanced that it spun silently for decades until the central pivot wore out in the 1980s. Modern engineers attempting to repair it were stunned by the accuracy of the borehole and the flawless distribution of mass. Astronomical alignments are woven throughout the site. A telescope he built points precisely at the North Star, and certain stones are positioned to mark the solstices. Coral Castle stands as a direct, tangible bridge between our modern world and the ancient mysteries. It proves that the puzzle of megalithic engineering did not end with the fall of Rome or the Inca. It persisted, resurfacing in the age of the automobile and the airplane, in the hands of a man who insisted the ancients held a secret we had lost. His life's work asks a haunting, personal question. If one man, working alone with 20th-century materials but pre-industrial tools, could move 30-ton stones, what does that imply about the collective, generations-long efforts of entire ancient civilizations? It suggests that the boundary between the impossible and the achievable may not be defined by technology, but by a kind of knowledge, a patient, intimate dialogue with the laws of physics that we are still struggling to relearn. Long before pharaohs ruled the Nile, a community of farmers on a small Mediterranean island performed an act of architectural audacity. On the island of Gozo, part of the Maltese archipelago, the Ġgantija temples rise from the landscape as silent, staggering proof of a Neolithic genius. Constructed around 3,600 years before the Common Era, these are among the oldest free-standing stone structures on Earth, older than Stonehenge, older than the Great Pyramid of Giza. They were built by a people with no metal, no wheels, and no written language, using only stone tools, rollers, and an immense collective will. The name itself, Ġgantija, means giantess in Maltese, a nod to local folklore that a giantess built these temples while carrying her child. Stepping through the monumental entrance, you are confronted by a facade of cyclopean blocks, some weighing over 50 tons, meticulously fitted together to form a curved wall that once stood perhaps 5 times taller than a person. The engineering technique here is corbelling, where each successive layer of stone is placed slightly inward, creating a domed ceiling that could span large interior spaces without collapsing. This is architecture on a colossal scale, conceived with a geometric understanding that feels out of place in its time. The temple complex is laid out in a distinctive cloverleaf plan, a series of interconnected, semicircular chambers or apses arranged around a central corridor. The precision of this layout is not random. Research suggests the apses are aligned with celestial events, perhaps the rising of certain stars or the solstice sun, weaving astronomy directly into the stone foundations. Inside, the atmosphere is one of profound quiet. Evidence shows the walls were once coated in a smooth plaster and painted with red ochre, a pigment with deep ritual significance. The spaces are dotted with altars, libation holes, and niches, all pointing to a vibrant, sophisticated spiritual life centered around a cult of a fertility goddess. Numerous statues of voluptuous female figures have been found here, emphasizing a reverence for creation, life, and the Earth's abundance. This context makes the logistical feat even more compelling. The Globigerina limestone used was quarried from a site several miles away. Moving these multi-ton slabs across the rocky island using only ropes, wooden sledges, and stone rollers represents a communal undertaking of staggering proportion and coordination. It forces us to ask what powerful social glue, what shared belief or visionary leadership could motivate a small farming community to dedicate generations to such a back-breaking, magnificent task. The temples were not homes or fortresses. They were centers of ceremony, community, and cosmic connection, built at a tremendous cost of labor and resources. Then, around 2500 before the Common Era, the site was carefully, deliberately abandoned. The reasons are lost, but the legacy is set in stone. Ġgantija represents humanity's early, breathtaking leap from building shelters to constructing monuments to the intangible. It is a testament to the fact that the drive to create meaning, to reach for the stars and honor the forces of life, can manifest in stone long before the advent of what we call civilization. This mysterious abandonment on a Mediterranean island finds a strange parallel on the other side of the world, where an entire city of stone was also left behind, frozen in time atop a remote mountain ridge. Scattered across the lush river deltas of southern Costa Rica, a different kind of perfection waits. Here, amid banana plantations and tropical foliage, lie hundreds of stone spheres, some as tall as a person, others the size of a large melon. Their surfaces are impossibly smooth, their shapes approaching geometric perfection. Known as the stone spheres of the Diquis, they were crafted by a pre-Columbian culture between 300 and 1500 of the Common Era, and they present a mystery of minimalist elegance. The engineering feat is not in moving mountains of stone, but in mastering the sphere itself. Creating a perfect or near-perfect sphere from solid rock without metal tools, lathes, or measuring calipers is an exercise in profound patience and three-dimensional intuition. The material itself, a hard, igneous rock called gabbro, was quarried from the nearby Talamanca Mountains. The process, as deduced by archaeologists, began with heating the stone with fire and then rapidly cooling it with water to create fractures. Then, using hammerstones made of an even harder material, workers would peck away at the surface, gradually removing material in a controlled manner. This was followed by endless hours of grinding with sand and water, slowly smoothing the surface into its final, breathtakingly round form. The level of skill required cannot be overstated. Maintaining consistent curvature across the entire surface with no flat spots or bulges demands a masterful eye and a deep, tactile understanding of form. It is sculpture as high-precision engineering. But why? What drove this culture to invest such immense effort into creating these silent, perfect orbs? Theories abound, each reflecting a different facet of their world. Some researchers, noting that many spheres were found arranged in lines or geometric patterns like triangles and parallelograms, propose they functioned as astronomical markers. Alignments may have pointed to celestial events or marked significant solar positions, turning the landscape into a giant observatory. Others see them as powerful status symbols, embodiments of authority and lineage, placed near the homes of chiefs to denote power and cosmic connection. A more poetic theory suggests the spheres represented celestial bodies, and their arrangements were maps of constellations, a way of bringing the night sky down to Earth. The tragedy, as local archaeologists often note, is that we have lost the context. Many spheres were looted or moved from their original positions during 20th century agricultural expansion, severing the physical clues that could have unlocked their meaning. We are left with the objects, but not the blueprint of their purpose. The logistical puzzle extends to movement. How were these multi-ton spheres, the largest weighing over 16 tons, transported from the quarries through dense jungle and across rivers to their final sites? The most likely method involved a combination of wooden sledges, rollers, and large teams of people, a testament to communal effort. Their varying sizes, from a few inches to over 2 meters, suggest a deliberate system, perhaps denoting rank or specific ceremonial functions. The stone spheres of Costa Rica stand as a testament to a different kind of ancient genius. This is not the drama of towering pyramids or sprawling temples, but the quiet, profound obsession with an ideal form. In their perfect geometry, we see a culture that sought to capture a universal truth, the purity of the sphere, and place it within their world. They remind us that ancient engineering marvels are not always about overwhelming scale. Sometimes they are about an idea made stone, a single, perfect question rolled silently across the centuries. Deep within the soft sandstone hills of Zhejiang province, a world exists that was never meant to be seen. In 1992, local farmers draining ponds made a discovery that would rewrite the region's history, revealing not a single tomb but an entire underground empire. The Longyou caves are a network of 24 colossal hand-carved caverns, spanning a staggering 30,000 square meters. To stand inside one is to feel dwarfed not by nature but by human ambition. The walls, ceilings, and massive support pillars are all covered in a mesmerizing, uniform pattern of parallel chisel marks, a signature of immense, organized labor. The scale of the work is the first staggering fact. Archaeologists estimate that nearly 1 million cubic meters of rock were painstakingly removed. To visualize that, imagine carving out a mountain of stone the size of 200 Olympic swimming pools using only handheld tools. This was not a haphazard excavation. The engineering is consistent and intelligent across all 24 caves. The ceilings are flat, supported by enormous, evenly spaced pillars left in place by the original diggers. The walls are slanted at precise, identical angles. Even more remarkably, each cave features a series of deep pools, carefully designed to maintain a specific water level, likely to counterbalance the immense pressure of the surrounding earth and prevent collapse. This is not simple digging. This is sophisticated subterranean architecture. Yet, for all its grandeur, the complex exists in a vacuum of history. No written record, no local legend, no pottery shard or tool left behind speaks of its creation. The silence is deafening. Who built this, when, and most perplexingly, why? The sheer volume of removed material poses a logistical nightmare of its own. 1 million cubic meters of rubble is a mountain in itself. Where did it all go? No massive spoil heap exists in the surrounding landscape. It simply vanished, as if the earth swallowed the evidence of its own transformation. Experts have proposed theories, each grappling with the scale. Some suggest the caves were an ancient quarry, providing stone for a nearby city that has since disappeared. Yet the interiors show signs of careful finishing and symbolic carvings of fish, horses, and birds, which seem more ceremonial than utilitarian. Others propose they were imperial tombs or hidden ceremonial spaces, perhaps for a ruler or a sect that demanded absolute secrecy. The acoustic properties of the chambers add another layer of mystery. The shape of the rooms and the pattern of the chisel marks create unique sound effects. Certain frequencies resonate powerfully, and sounds can carry clearly from one side of a cavern to the other. Was this an intentional feature, designed for ritual chanting or communication? The fish and bird carvings, often associated with water and sky in Chinese symbolism, might hint at a spiritual purpose, a desire to unite the underworld with the heavens. The Longyou caves stand as a monument to a collective act of will that history chose to forget. They represent a project of staggering, organized labor that was then meticulously erased from memory. This deliberate silence is as much a part of the engineering marvel as the slanted walls and the support pillars. It defies logic not just in its physical scale, but in its complete detachment from the story we tell about the past. A civilization capable of such a coordinated, underground effort simply could not leave no other trace, unless, of course, we are looking in the wrong places or reading the evidence with the wrong eyes. This pattern of a magnificent, unexplained structure standing in historical isolation is not unique to China. It echoes across the globe, finding a parallel in a city of stone that seems to have been abandoned almost as soon as it was completed. A different kind of perfection stands not in a jungle or a cave, but in the heart of a bustling city. In Delhi's Qut complex, surrounded by the ruins of later empires, a single iron column has defied one of nature's most relentless laws for over 1,600 years. The Iron Pillar of Delhi, forged in the 4th century of the Common Era, rises 7 meters tall, a testament not to scale, but to a secret locked within its molecular structure. In a region known for humid monsoons and scorching heat, a metal object exposed to the elements for a millennium and a half should be a crumbling, reddish-brown relic. Yet this pillar remains smooth, strikingly intact, with only the faintest patina. It is, for all practical purposes, rust-proof. This is not an accident of preservation. It is a deliberate, sophisticated achievement of ancient metallurgy that modern science has only recently begun to fully appreciate. The marvel lies in its composition. The pillar is made from wrought iron of exceptional purity, but its true genius is a deliberate high phosphorus content. This was no common impurity. Ancient Indian metalworkers, known as the Vishwakarma, appear to have intentionally added phosphorus-rich materials during the smelting process. The result was a unique alloy that, when exposed to air, forms an extraordinarily thin, stable film of iron-hydrogen phosphate hydrate across its surface. This film, just microns thick, acts as a self-healing protective barrier. It prevents oxygen and moisture from penetrating deeper into the metal, halting the corrosion process in its tracks. This knowledge represents a quantum leap in materials science. Creating such an alloy required a profound, likely empirical, understanding of ore selection, furnace chemistry, and forging techniques. They were not just making iron strong, they were engineering it to be timeless. The pillar itself carries a message from its creators. An inscription in Sanskrit, etched into its surface, records that it was erected as a standard or flagstaff in honor of the god Vishnu by a king named Chandra, likely Chandragupta II. It originally stood elsewhere, possibly at a Vishnu temple complex, before being moved to its current location centuries later. This context is vital. It was not a utilitarian support beam. It was a sacred object, a divine axis mundi connecting earth and heaven, meant to endure for eternity as an act of devotion. The fact that such advanced technology was deployed for a spiritual monument speaks volumes about the values of that society. Scientific studies over the past century have only deepened the wonder. Researchers from institutions like the Indian Institute of Technology have analyzed the pillar extensively, confirming the uniform phosphorus distribution and the remarkable thinness of the protective layer. They have also noted the sheer skill of its forging. The pillar was created by hammer welding individual pieces of hot iron together into a single, solid mass, a technique requiring immense control to avoid introducing weaknesses. Yet this pinnacle of technology presents its own profound mystery. Why was this rust-resistant formula not replicated and spread across the ancient world? Why does the pillar stand as a solitary, unmatched example? The knowledge may have been a closely guarded secret of a specific guild of smiths, lost when that guild faded away. It might have been tied to the availability of specific, regional ores, or perhaps the immense cost and effort required for such purity made it impractical for widespread use, reserved only for the most sacred of projects. Whatever the reason, the Iron Pillar of Delhi stands as a powerful counterpoint to the story of linear, cumulative progress. It is a clear, physical peak of knowledge that was reached, celebrated, and then somehow left behind. It forces us to ask what other peaks of understanding in other fields might have flared brilliantly and then vanished, leaving only a single, rustless pillar in a field of ruins to hint at what was once possible. A hilltop in southeastern Turkey holds a secret that shatters the timeline of human history. At Göbekli Tepe, around 9,600 years before the Common Era, hunter-gatherers accomplished something that, according to every textbook, should have been impossible. They built the world's first known monumental temple, a complex of stunning sophistication, a full 6,000 years before Stonehenge and millennia before the invention of agriculture, pottery, or metal tools. This is not merely an old site. It is a revolution in stone, forcing us to rewrite the story of civilization itself. The engineering marvel is both simple and staggering. From the local limestone bedrock, workers quarried, carved, and erected massive T-shaped pillars, some standing 16 feet tall and weighing between 10 and 20 tons. These are not crude posts. They are works of art and symbolic architecture, each monolith shaped like a stylized human form with carved arms, hands, and belts. Their surfaces are a menagerie of intricate bas-reliefs, a snapshot of a symbolic world teeming with foxes, cranes, scorpions, lions, and boars, creatures rendered with a fluid, confident artistry that speaks of a rich mythological tradition. The pillars were arranged in a series of circular and oval enclosures, with two particularly large central pillars surrounded by slightly smaller ones, all interconnected by low stone walls. The scale of the labor involved is immense, quarrying these multi-ton pillars from the solid bedrock using only flint tools and transporting them hundreds of feet to the hilltop summit represents a communal undertaking of breathtaking coordination and shared purpose. It was a project that would have required feeding and organizing hundreds of people over generations, all without the settled farms or permanent villages we assumed were necessary for such endeavors. This is the core of Göbekli Tepe's paradox, a point powerfully articulated by its lead excavator, the late Klaus Schmidt. He proposed a radical idea that turned conventional theory on its head. Perhaps it was not agriculture that made monumental architecture possible. Perhaps it was the other way around. The compelling need to build and maintain this sacred sanctuary, this spiritual center for scattered hunter-gatherer bands, required a large, stable workforce. To feed these builders, the people may have begun to cultivate wild grasses and manage wild animals in the surrounding hills, slowly nudging nature toward domestication. In this view, organized religion and large-scale communal projects were not the products of a settled agricultural surplus. They were the engine that created it. The temple drove the farm. The design of the enclosures suggests a mind attuned to more than just symbolism. Some researchers studying the layout propose that the arrangements of the pillars hold astronomical significance, potentially aligned to mark solstices or significant star cycles. This hints that the builders were not just artists but early astronomers, mapping the heavens onto their sacred ground. Then, around 8,000 before the Common Era, after centuries of use, the people of Göbekli Tepe performed a final, deliberate act. They buried their entire monumental creation. They brought thousands of tons of earth and rubble and filled the enclosures to the brim, preserving the pillars and their carvings for 12,000 years until their rediscovery. This was not an attack or an abandonment. It was a ritual entombment, a careful closing of a sacred chapter. Why they did this remains one of its deepest mysteries. Did their beliefs change? Was the site meant to be a capsule for a specific era of their spiritual understanding? Göbekli Tepe stands as a profound challenge to the logical sequence of cultural development. It presents a world where symbolic thought and architectural ambition reached a towering peak before what we call civilization even began. It asks us to consider that the human impulse to create meaning, to build together towards something greater than ourselves, may be the original catalyst for everything that followed. This sanctuary suggests that society did not invent the temple. The temple, in many ways, invented society. The ocean floor holds a secret that blurs the line between a natural wonder and a lost world. Off the southern coast of Japan's Yonaguni Island, divers descend into clear blue water to find a sight that defies easy explanation. Rising from the seabed is a colossal, terraced structure, a series of massive platforms with sharp, 90-degree angles, straight walls, and what look like perfectly carved steps. At its summit lies a broad, flat plaza, and nearby stand formations that resemble a giant turtle, twin pillars, and a star-shaped platform. The entire complex, dubbed the Yonaguni Monument, stretches over 150 meters long and rises 25 meters high, a submerged mountain of geometric mystery. The core question is simple yet profound. Is this a stunning accident of geology, or is it the drowned architecture of a civilization from a time before recorded history? The debate places us directly at the intersection of two sciences, each with its own compelling narrative. On one side, marine geologists like Robert Schoch point to the powerful natural forces at work. The structure is composed of sandstone, a rock prone to fracturing along natural bedding plains. The strong currents in the area, combined with seismic activity from the nearby Longyou Trench, could have eroded the rock along these lines, creating the appearance of platforms and steps. The seeming right angles and flat surfaces, they argue, are a classic example of pareidolia, the human tendency to see familiar patterns, especially faces and structures, in random shapes. They note that similar, though smaller, angular formations exist in other underwater sandstone sites around the world, formed entirely without human intervention. The scientific principle of Occam's razor suggests the simplest explanation is often the correct one. In this view, Yonaguni is a magnificent geological sculpture shaped by millennia of water and tectonic movement. Yet for proponents like researcher Graham Hancock and the late discoverer of the site, Kirkiro Aratek, the monument tells a different story. They highlight specific features that seem to defy natural explanation. The so-called monolithic turtle is a large, raised block with a strikingly clean, beak-like protrusion. The twin pillars are two massive, parallel stone columns that appear purposefully placed. Most compelling is the star-shaped platform, a formation with precise, radiating angles that feel deliberately designed. Perhaps the most haunting features are what some interpret as carved faces or animal reliefs on certain walls, though these are more subjective and heavily debated. These proponents argue that the combination of so many geometric and symbolic elements in one place stretches the limits of coincidence. They tie the site to global legends of a great flood and lost continents, suggesting it could be a remnant of a pre-glacial civilization, submerged when sea levels rose dramatically at the end of the last ice age, over 10,000 years ago. Local lore adds a layer of poignant context to this theory. On Yonaguni Island, there are old tales passed down through generations, stories of a sunken city that once existed offshore. While such myths are common in coastal communities worldwide, their proximity to the physical structure gives them a tangible weight. The difficulty of definitive proof, however, is immense. Underwater archaeology is notoriously challenging. Dating a stone structure submerged for millennia is problematic. Traditional methods like carbon dating require organic material, and any potential artifacts or tool marks have been smoothed by 12,000 years of relentless currents. Without an inscription, a pottery shard, or an unequivocally man-made tool found in situ, the debate remains in a stalemate between interpretation and hard evidence. Yonaguni does not offer easy answers. It presents a riddle written in stone on the ocean floor, whether a masterpiece of natural forces or a monument from a forgotten epoch. It challenges our understanding of human history and the planet's dramatic changes. It forces a humbling consideration. If the seas rose hundreds of feet after the Ice Age, what other chapters of human endeavor now lie buried beneath the waves, waiting for a current to shift the sand and reveal another set of impossible angles? This idea of a lost world beneath the water finds a strange echo far inland, where an entire city was carved not into the earth but directly into the face of a cliff. Across the wind-swept coast of Brittany, a different kind of code is written not in a single structure, but across the entire landscape. The Carnac alignments are a forest of stone grown from the earth, over 3,000 prehistoric menhirs standing in eerie, parallel rows that march for kilometers across the fields. This is not a temple you walk into, but a system you walk through, a vast open-air diagram whose purpose has been debated for centuries. The sheer scale of the coordination is the first staggering fact. The three major alignments of Menek, Kermario, and Kerleskun comprise nearly 3,000 stones, arranged with a geometric intention that feels both methodical and mysterious. Some of these granite pillars weigh over 300 tons, quarried from local outcrops and erected by a Neolithic society over 6,000 years ago. The physical effort to position this army of stone is a marvel of prehistoric logistics, implying a society with remarkable unity, leadership, and a shared vision powerful enough to motivate generations of labor. But the greater mystery lies in why they did it. What compelled them to transform their world into this monumental grid? For researchers like Alexander Thom, who meticulously surveyed megalithic sites across Europe, the answer was written in the sky. He proposed that the alignments functioned as a sophisticated astronomical observatory. The long, straight rows are not randomly oriented. Many are aligned to the rising and setting points of the sun at the solstices, the most extreme points of its yearly journey. Others may have tracked the more complex 18.6-year cycle of the moon, allowing the builders to predict lunar standstills and even eclipses. In this view, the stones were not passive monuments, but active components in a giant stone computer used to calibrate the calendar, essential for an agricultural society to time planting and harvests and to mark sacred celestial events. Walking among the rows, one can feel this potential. The stones create sight lines, framing the horizon in specific segments. A priest or astronomer standing at one end of a row, or at a particular fan-shaped arrangement, could watch the sun or moon rise directly over a keystone at a specific time of year, turning the landscape into a dynamic, interactive clock. Yet astronomy is not the only theory. The very placement of the stones, their deep insertion into the ground, has led some researchers to propose a function tied to the Earth itself. Given the region's geology, could the alignments have served as a primitive seismic detector? The idea suggests that the stones, set in loose soil above bedrock, might vibrate or produce audible sounds in response to subtle seismic waves from distant earthquakes, serving as an early warning system for a coastal community. This theory, while speculative, speaks to a potential practical genius, a harmony with the natural forces that surrounded them. The site is also a complex ceremonial landscape. Scattered among the grand alignments are other types of monuments, including dolmens, which are stone table tombs, and tumuli, which are large earthen mounds covering burial chambers. This combination suggests the alignments were part of a broader ritual geography, perhaps a pathway for processions connecting the realms of the living, the dead, and the cosmos. The journey from the rows of standing stones to a sealed burial mound could have represented a spiritual passage, guided by the very stones that also charted the passage of the stars. The Carnac stones resist a single, simple explanation. They could have been all of these things at once: an astronomical calculator, an earth sensor, and a sacred pathway, their meaning layered like the landscape itself. They represent a different kind of ancient engineering, one of vast spatial planning and environmental integration. The message they encode is not in intricate carvings, but in their relationship to each other and to the horizon. It is a message about pattern, cycle, and connection, a Neolithic attempt to map the order of the universe onto the face of the Earth, a code we are still patiently learning to read. The precise grid of a city can be a map of the cosmos. High on the central Mexican plateau, the ruins of Teotihuacan stretch across the valley in a silent, geometric dream. From above, the city reveals its staggering secret. The Avenue of the Dead, the central axis, runs arrow straight for over 2 miles, flanked by the massive Pyramid of the Sun and culminating at the Pyramid of the Moon. But the true marvel is not in any single structure. It is in the invisible lines connecting them, a layout that some researchers believe is a scale model of our solar system. The distances between the city's major monuments appear to be proportionally accurate to the orbital distances of the planets from our Sun. The Pyramid of the Sun may represent the Sun itself, with the Pyramid of Quetzalcoatl and the Pyramid of the Moon standing in for the orbits of Earth and Venus, or perhaps more distant planets. This is not a loose approximation. The work of researchers like Hugh Harleston Jr. suggests the builders used a precise unit of measurement, now called the Teotihuacan unit, equivalent to about 83 centimeters. When the site is measured using this unit, the proportions between structures produce ratios that eerily echo the known spacings between planetary orbits. This implies a sophisticated, encoded knowledge of celestial mechanics over 2,000 years ago, a science woven directly into the urban fabric. Who were these master planners? Ironically, the name we use for the city, Teotihuacan, means the place where the gods were created, a name given by the Aztecs who found the magnificent ruins centuries after its fall. The original builders remain anonymous, a civilization that left no deciphered written records, only this monumental testament to their mind. Their identity is lost, but their organizational genius is unmistakable. Archaeologists like René Millen, who mapped the entire city, highlight the evidence of supreme central planning. The metropolis was laid out on a rigid grid, with standardized apartment compounds housing a diverse population that may have reached 125,000 people. These were not haphazard dwellings. They were uniform in design, built with a shared vision of order and community, suggesting a society with a powerful, perhaps theocratic, leadership capable of coordinating generations of labor toward a unified cosmic vision. This astro-architecture extended beyond mere distances. The orientation of the entire city, 15.5 degrees east of true north, is not arbitrary. It aligns with the setting point of the Pleiades star cluster on the horizon, a celestial event of deep significance in Mesoamerican cosmology. The Pleiades were associated with the agricultural cycle and with cosmic renewal. By aligning their entire world to this star group, the people of Teotihuacan were literally building their calendar and their connection to the heavens into the foundation of every street and wall. The city was a living machine designed to harmonize human activity with the rhythms of the universe. What does this mean for our understanding of their daily life? It suggests a world view where the sacred and the scientific were inseparable. The precise unit of measurement used to lay out solar system proportions was the same unit used to build a family's apartment. The cosmos was not a distant abstraction. It was the blueprint for society, a constant physical reminder that their community was a direct reflection of a larger, orderly universe. This integration of cosmology into urban planning represents a pinnacle of ancient thought, a lost science where architecture became astronomy and a city became a model of the heavens. Teotihuacan stands as a challenge to our fragmented modern perspective, asking us what it means to build a civilization in conscious harmony with the stars. Clinging to the sheer face of Mount Heng, a temple seems to grow directly from the rock itself. The Hanging Temple of Hengshan, constructed over 1,500 years ago during the Northern Moai dynasty, is a masterpiece of architectural defiance. It is not built upon the mountain, but into it, a complex of 40 halls and pavilions that appear to float in mid-air, suspended above a deep canyon. This is not an illusion of perspective. The temple truly hangs, a wooden labyrinth anchored to a vertical cliff, challenging the most basic rule of construction, that a building must have a foundation on solid ground. The builders faced a seemingly impossible task. How do you create a stable, multi-story structure on a 90-degree surface, in a location battered by powerful winds, seasonal floods from the river below, and the ever-present threat of earthquakes? Their solution was a breathtaking blend of observation, mechanics, and profound philosophical insight. The core engineering secret lies in a hidden support system. Deep holes were chiseled into the solid cliff face. Into these holes, massive crossbeams of resilient oak were inserted, penetrating several meters into the rock. These beams act as the primary cantilevers, the hidden bones of the temple. The wooden pavilions are then constructed outward from these anchored beams, with their weight carefully distributed so that the structure is partially supported by the beams and partially braced against the cliff itself, which acts as a solid, immovable back wall. This design employs principles of leverage and weight distribution that would make a modern engineer nod in respect. The entire complex is a lesson in balance, with heavier halls positioned lower and closer to the cliff, while lighter structures extend further out, creating a stable, integrated mass that moves and flexes as one with the mountain. This harmony with the natural environment was not merely practical. It was deeply spiritual, inspired by Taoist philosophy which emphasizes living in accordance with the natural world, not in opposition to it. The builders did not seek to conquer the cliff, but to collaborate with it, using its immutable strength to achieve their soaring vision. This collaboration is tested by the elements constantly. The temple's unique position, nestled under a prominent overhang, protects it from most rainfall and sunlight, slowing the decay of its wooden components. Its flexible, jointed wooden frame allows it to sway and absorb the energy of high winds and seismic tremors, rather than resisting and shattering. For over a millennium and a half, it has withstood everything nature could deliver, a testament to the foresight of its creators. Walking through the temple is an experience of controlled vertigo. Narrow, winding boardwalks and steep staircases connect the various pavilions, each dedicated to a different spiritual tradition. Here, Buddhist, Taoist, and Confucian altars and statues exist side by side, a rare and symbolic integration of China's three major philosophies into a single, perilous sanctuary. This was intentional. The location itself, between heaven and earth, was seen as a perfect place for contemplation and unity, a physical manifestation of the quest for balance between different ways of understanding the world. The Hanging Temple is more than a feat of survival. It is a poem in wood and stone. It demonstrates that the most audacious engineering emerges not from a desire to dominate a landscape, but from a deep, observant dialogue with it. The builders looked at a vertical cliff and saw not an obstacle, but an opportunity, a partner in creating something that defied gravity and time through harmony, not force. This same principle of integrating structure with the living earth finds a different, even more mysterious expression in a place where the stones themselves seem to have been grown, not built. 2,000 years of saltwater and storms have only made it stronger. While modern concrete harbors crumble after mere decades, the ancient Roman port of Caesarea Maritima still stands, its colossal breakwaters defiantly resisting the relentless Mediterranean. The secret lies not in some mystical power, but in a brilliantly counterintuitive recipe, a form of material science so advanced that we have only recently begun to decode its genius. Roman concrete was not just durable, it was a living material designed to thrive in the very environment that destroys our own. At its heart was a simple, volcanic ingredient known as pozzolana, a fine ash mined from regions like Pozzuoli near Mount Vesuvius. When Roman engineers mixed this ash with lime and seawater, they initiated a chemical conversation that continues to this day. Modern Portland cement, the basis of our concrete, reacts with water in a single, finite process that eventually ends, leaving it vulnerable to cracking. Seawater then infiltrates those cracks, corroding the steel reinforcements within and causing catastrophic failure. The Roman formula worked in reverse. Seawater was not the enemy, it was the catalyst. When seawater percolates through Roman concrete, it slowly reacts with the volcanic ash and lime to form a rare, plate-like mineral called aluminous tobamorite. This mineral grows and interlocks over centuries, filling microscopic pores and actually strengthening the concrete from the inside out. The material literally heals itself, becoming more monolithic with time. This process was recently unraveled by geologist Marie Jackson and her team, who used advanced imaging to peer into the atomic structure of ancient Roman samples. They discovered a complex, layered crystallization that modern chemistry struggles to replicate. The Romans achieved this not by accident, but through meticulous, scaled engineering. Constructing a harbor like Caesarea required another breathtaking feat: underwater pouring. They could not simply drop bags of dry mix into the sea. Instead, they built temporary wooden forms directly on the seabed. Then, using a precise, rapid process, they mixed the pozzolana concrete on barges and poured it directly into these submerged molds. The concrete would set and cure even in the water, creating seamless, monolithic blocks that were part of the seafloor itself. This technology provided an overwhelming strategic and economic advantage for the empire. It allowed Rome to build deep water ports anywhere, securing supply lines for its legions and creating hubs for trade that fueled its economy. The durability meant harbors required minimal maintenance, freeing resources for further expansion. It was infrastructure as empire building, a physical network of stone and mortar that bound the Mediterranean world together. The environmental lesson is profound. The production of modern Portland cement is a major source of global carbon emissions, requiring immense heat to process limestone. The Roman recipe used far less lime and harnessed natural volcanic materials, resulting in a process that was significantly less energy-intensive and far more sustainable over the long term. Today, scientists like Jackson are working to create modern versions of this ancient concrete, hoping to build seawalls and tidal barriers that can endure for millennia, not just for decades. Roman concrete stands as a humbling testament to a different kind of progress. It proves that advancement is not always a linear path of improvement. Sometimes the most elegant, resilient solutions are discovered, widely implemented, and then inexplicably forgotten, waiting centuries for us to rediscover their wisdom. This mastery of materials to defy the elements finds a parallel in a structure that seems to defy gravity itself, not with chemistry but with a perfect, silent balance. The stone walls of Great Zimbabwe curve and flow like a river frozen in time. Far from the Mediterranean or the Andes, in the heart of southern Africa, a different kind of architectural genius flourished between the 11th and 15th centuries. This was not a city built by outsiders, but by the Shona people, a civilization whose mastery of trade and engineering created one of the largest and most sophisticated stone complexes in all of Africa. The marvel here is one of elegant, self-reliant construction, a technique known as dry stone walling. Without a single drop of mortar, without any binding agent at all, the builders created walls that have stood for nearly 1,000 years, their stability born from pure, patient skill. Each granite block was carefully selected for its shape and size, then painstakingly fitted to its neighbor. The walls taper gently inward as they rise, and the most impressive of them, like those of the great enclosure, curve in graceful, serpentine lines that defy the rigid geometry of so many other ancient sites. This curvature was not merely aesthetic, it served a vital structural purpose, distributing weight and stress evenly, allowing these towering walls, some over 30 feet high and 20 feet thick at the base, to withstand the test of centuries through sheer intelligent design. At the center of this stone labyrinth stands the iconic conical tower, a solid, majestic structure whose exact purpose remains a subject of scholarly discussion. Was it a granary, a symbol of royal authority, or a spiritual beacon? Its silent presence only deepens the site's profound aura. The sophistication of Great Zimbabwe extended far beyond its walls. This was the capital of a wealthy kingdom that controlled the lucrative gold trade routes from the interior of Africa to ports on the Indian Ocean coast. Arab and Swahili merchants traded glass beads, Chinese porcelain, and Persian fabrics for the region's gold and ivory, making Zimbabwe a cosmopolitan hub of global commerce long before European ships rounded the Cape of Good Hope. The famous soapstone carvings of the great Zimbabwe bird, found on monoliths throughout the ruins, likely served as emblems of royal power and spiritual guardianship, linking the kingdom to the ancestral world. Historians studying the site note that the layout itself reveals a complex social hierarchy. The hill complex, perched on a granite dome, is thought to have been the spiritual and royal center. The valley enclosures below housed the elite, while the great enclosure, with its massive, imposing walls, may have been a royal residence or a ceremonial space for the court. This zoning reflects a highly organized society with distinct roles and a powerful central authority capable of mobilizing labor for grand projects. The engineering intellect of the Shona builders is further evidenced in their mastery of their environment. In a region with a distinct wet and dry season, water management was crucial. Archaeologists have uncovered evidence of sophisticated hydraulic systems, including carefully lined drains and channels that directed rainwater from the stone enclosures into designated cisterns and reservoirs. This ensured a reliable water supply for the city's inhabitants and their livestock throughout the year, a practical necessity for a thriving urban center. Furthermore, research suggests certain structures and openings within the complex were aligned with astronomical events, such as the rising of specific stars or the solstice sun. This celestial orientation wove a layer of cosmic order into the daily life of the city, connecting the rhythms of trade and governance with the larger cycles of the heavens. For many years, colonial narratives refused to believe that an indigenous African civilization could have created such a monumental and advanced city. Outdated and erroneous theories credited outsiders, from Phoenicians to Arabs, for its construction. The ruins of Great Zimbabwe stand as a powerful, stone-built rebuttal to those myths. This was an independent, innovative center of African achievement, a testament to a homegrown engineering tradition that required no imported blueprint. Its full story, from the precise sourcing of each stone to the details of its daily life, is still being patiently uncovered by archaeologists, piece by fitted piece, restoring a magnificent chapter to the global history of human ingenuity. A staircase does not always lead upward. In the arid plains of Rajasthan, the ground opens into a geometric chasm, a cavern of perfect order carved from the thirst of the land itself. Chand Bayori in Abhanari is not a building that rises, but one that plunges, a staggering inverted pyramid descending 13 stories into the earth. Built in the 9th century of the Common Era, this is not merely a well. It is a breathtaking symphony of stone and water, comprising 3,500 precisely arranged steps that cascade down 3 of its 4 sides in a mesmerizing, symmetrical cascade. To stand at its rim is to gaze into a man-made canyon of breathtaking geometric precision, a testament to an engineering philosophy where necessity and transcendence were one and the same. The primary marvel is hydrological genius. In a region plagued by long, punishing droughts, the stepwell was a monumental solution for water conservation. Its vast square shaft was designed to capture and store every precious drop of monsoon rainfall. The engineering is deceptively simple yet profoundly effective. The steps themselves, arranged in a repetitive, crisscrossing pattern, create a massive surface area that slows the water's flow into the deep central reservoir, minimizing silt and turbulence. The sheer depth and the step design also drastically reduce evaporation, shielding the water from the scorching sun and dry winds at the surface. This was a community's lifeline engineered into the landscape, a guarantee of survival etched in stone. But Chand Baori was far more than a utilitarian tank. It was a vibrant, multi-level social universe. While the lower steps accessed the water for daily drawing, the upper levels transformed into a cool, subterranean plaza. Elaborate pavilions, arched galleries, and carved balconies line the 4th, vertical wall, providing shaded spaces for gatherings, rituals, and respite from the desert heat. The temperature difference between the sun-baked surface and the cool, moist air at the bottom could be dramatic, making the stepwell a natural refuge. Architectural historians often describe it as a breathtaking inversion of a pyramid or a temple, where the act of descent becomes a spiritual and social journey. The structure manipulates space with a mathematician's grace, drawing the eye and the body downward into a realm of quiet reflection and community life. This fusion points to the deep cultural significance of stepwells across India. They were considered sacred, often dedicated to deities, and the act of descending to collect water was intertwined with ritual purification and prayer. The very architecture enforced a rhythm of life, connecting the practical need for water with moments of social interaction, ceremony, and quiet contemplation. Women, who are primarily responsible for water collection, would often linger on the steps, sharing news and fostering community bonds in the cool shade. Chand Baori, in its staggering scale and beauty, represents a pinnacle of this tradition. It reflects an advanced form of civic planning that considered not just physical survival, but social and spiritual well-being. Every carved column, every symmetrically placed step, served a dual purpose, marrying mathematical elegance with deep human need. It stands as a monumental lesson in sustainable design, showing how a society can confront an environmental challenge not with a hidden pipe or a simple hole, but with an architectural masterpiece that celebrates the resource it preserves. This is engineering as reverence, a staircase to water that also ascends to the heights of communal art. A different kind of tomb lies in the desert dark. Deep below the sands of Saqqara, far from the sunlit pyramids, a straight, subterranean corridor stretches into absolute blackness. Carved from the living bedrock, this tunnel is lined with side chambers, and within each rests a single, silent object. It is a polished box of rose granite, so immense it seems to swallow the dim light. This is the Serapeum, and its 25 sarcophagi present a puzzle not of hieroglyphs, but of pure, impossible geometry. Each monolithic container weighs between 70 and 100 tons with a lid of equal mass. They are not rough-hewn. They are exercises in flawless precision that feel out of place in the ancient world. The interior surfaces are polished to a mirror finish, a glassy smoothness that reflects your own confusion back at you. The corners are sharp, perfect 90-degree angles meeting in razor-precise edges. Running your hand along the inside, you feel no tool marks, no chisel scars, only an unsettling, machined perfection. This is the heart of the mystery. Granite is one of the hardest stones on Earth, rating a 7 or 8 on the Mohs scale. To shape it with the presumed tools of the era, copper chisels and abrasive sand, should leave a distinctive, scratched surface. Yet the finish here suggests something else, something closer to modern precision milling or diamond-tipped sawing. The flatness is so absolute, the corners so exact, that it implies the use of advanced, fixed machinery capable of making repeated, identical cuts with immense stability. How could a culture working with handheld tools achieve this? The logistical feat of their placement deepens the wonder. These colossi were quarried from Aswan, over 500 miles away, brought to the site, lowered down a deep shaft, and then slid into their side chambers along the main tunnel. The final act, placing the multi-ton lids onto their boxes with a perfect seal in such confined underground spaces, is a ballet of engineering that staggers the imagination. The official explanation, supported by mainstream Egyptology, is that the Serapeum was a sacred burial vault for the Apis bulls, incarnations of the god Ptah. Inscriptions from later periods and the discovery of smaller, inscribed bull sarcophagi in other parts of the complex are cited as evidence. According to this view, the giant boxes held the mummified remains of these revered animals, and the precision was an expression of ultimate religious devotion, a desire to create an eternal, flawless vessel for a divine being. The fact that the boxes were found empty is attributed to ancient looting, yet for alternative researchers and engineers who study the site, the emptiness is a clue, not a conclusion. They point to the sheer over-engineering of the boxes. Why would a burial vault, even for a sacred bull, require a 100-ton container with a mirror finish and perfect internal geometry? The technical effort seems disproportionate to the stated purpose. This has led to more speculative theories. Some propose the boxes were not designed for burial at all, but for a functional purpose, perhaps as resonant chambers in a larger, energy-based system, or as sealed containers for a process now lost to time. The very precision, they argue, is the fingerprint of a technology we do not understand, a remnant of a different kind of knowledge applied to stone. The Serapeum offers no inscriptions on its giant boxes to settle the debate. It offers only the boxes themselves, cold, perfect, and silent. They sit in their dark chambers as the ultimate tactile riddle. Do they represent the pinnacle of ritual craftsmanship, a devotional art pushed to its absolute limit? Or are they artifacts of a different intent, a functional machinery whose purpose was buried along with the method of its making? To stand beside one is to feel the weight of both possibilities, 100 tons of polished mystery waiting in the dark, a single block of andesite standing alone on a windswept plateau holds a frozen language of gods and stars. The Gate of the Sun at Tiwanaku is not merely an entrance to a vanished city. It is a cryptic document carved in stone, a testament to a culture that saw time not as a straight line, but as a celestial wheel etched into the very fabric of their world. This monumental gateway, carved from a single block of stone weighing over 10 tons, is a canvas of intricate, low-relief iconography that has resisted definitive translation for centuries. At its center looms a dominant figure, often identified as Viracocha, the creator god in later Inca mythology. He stands rigid, holding staffs in both hands, while tears stream from his eyes, a powerful image of a weeping deity. Radiating from this central form are 48 squares, each containing a winged figure, 32 with human faces and 16 with condor heads. This precise, symmetrical arrangement is the core of the mystery. Many researchers, including Austrian engineer Arthur Posnanski, who spent decades studying the site in the early 20th century, believe this is not random art. They propose it is a sophisticated calendar, an astronomical record encoded in geometric patterns. The mathematics are compelling. The 48 figures could represent a system for tracking both solar and Venusian cycles. Some interpretations suggest the gate encodes a 290-day solar year and a 294-day synodic cycle of Venus, a complex interweaving of earthly and celestial timekeeping that required profound observational skill. The gate's placement is equally intentional. It is aligned so that on the morning of the September equinox, the first rays of the sun strike directly through its central portal, illuminating the figure of Viracocha in a dramatic display of light and shadow. This was a civilization that built its cosmology into the orientation of its monuments, turning architecture into a working astronomical instrument. The age of Tiwanaku adds another layer of profound controversy. While mainstream archaeology dates the site's major construction to between 300 and 1000 of the Common Era, Poznański and later researchers like Graham Hancock have pointed to geological and astronomical data suggesting a far older origin. They argue that the site's original alignments match the sky as it would have appeared over 15,000 years ago, a claim that, if true, would shatter conventional timelines and place Tiwanaku in a lost epoch of prehistory. This debate remains unresolved, a scientific friction that only deepens the site's aura of mystery. The gate itself is a masterpiece of precision engineering, its sharp, clean lines and deep carvings showcasing the same advanced stoneworking skills seen at nearby Puma Punku. This technological consistency is evident in other site marvels, like the Stoic Ponce monolith, a finely carved statue whose geometric proportions and smooth surfaces speak of a shared, highly refined artistic and engineering tradition. Yet for all its sophistication, Tiwanaku met a sudden and enigmatic end. Around 1000 of the Common Era, the city was abandoned. The reasons are unclear, with theories ranging from a prolonged, catastrophic drought that shattered the agricultural system to internal social upheaval. The culture's knowledge, including the full meaning of their stone calendar, seems to have evaporated with them, leaving only the silent gate and its weeping god. The Gate of the Sun, therefore, is more than a relic. It is a locked book. We can see the characters, the precise arrangement of its symbols, and we can measure its alignment to the solstices. But the full narrative, the specific stories, prophecies, or warnings it was meant to convey, remains just out of reach. It stands as a stark reminder that a civilization's greatest wisdom can be rendered mute by time, its most important messages left waiting in stone for a future that may never learn to read them. A carving on a dark temple wall seems to show a technology out of time. Deep within the crypts of the Hathor Temple at Dendera, Egypt, a series of enigmatic reliefs have sparked one of the most enduring modern debates about ancient knowledge. One panel in particular shows a priest holding a large, bulbous object, inside of which a snake stretches toward a lotus flower. A cable seems to connect the bulb to a box held by a smaller figure, and the entire scene is supported by a pillar with human arms. To many who first see it, the resemblance is startling. It looks for all the world like a giant, archaic light bulb, complete with a filament and a power source. This is the so-called Dendera light, and it presents a marvel not of stone or scale, but of interpretation. What are we actually looking at? The mainstream Egyptological explanation is rich with symbolic meaning, grounded in well-understood mythology. Egyptologists identify the scene as a representation of the creation myth centered on the god Harsomptis. The bulb is not a bulb, but the womb of the sky goddess Nut. The snake is the deity himself, depicted in his serpent form. The lotus flower from which he emerges symbolizes birth and creation, and the pillar is the Djed pillar, a symbol of stability and the backbone of the god Osiris. The entire tableau is a spiritual allegory for the moment of divine emergence, a sacred snapshot of cosmic genesis carved in stone. It fits seamlessly within the temple's purpose, which is dedicated to Hathor, goddess of love, joy, and motherhood. The context of the location is critical. These reliefs are found in subterranean, enclosed crypts, places meant for storing sacred votive items, not for public ceremony. The walls of these chambers, and indeed the ceilings of many ancient Egyptian tombs, are often covered in a layer of ancient soot, a clear testament to the use of oil lamps and torches for illumination. This physical evidence strongly suggests that the brilliant artists who covered these walls in intricate hieroglyphs and scenes worked by the flickering, smoky light of open flames. Yet the alternative theory, popularized by researchers like Erich von Däniken, asks a compelling practical question. How could such fine, detailed work be accomplished in deep, windowless tombs with only torches that consume oxygen and cover everything in soot? The proponents of the light bulb theory point to the carving's mechanical appearance. The snake is held rigid within the bulb by what look like supports. The cable connects to a box that could be interpreted as a power source, perhaps a battery. This line of thinking often references the famous Baghdad battery, a clay jar from 2,000 years ago containing a copper cylinder and an iron rod, which, if filled with an acidic electrolyte like vinegar, could produce a small electrical charge. While most archaeologists believe the Baghdad jar was used for electroplating or held scrolls, its existence fuels speculation about forgotten electrochemical knowledge. The debate at its heart is about the lens through which we view the past. One side sees a profound and coherent mythology expressed through symbolic art. The other sees a potential literal diagram of a lost technology, a spark of practical genius misinterpreted as myth. The truth likely lies firmly with the symbolic interpretation, as it is consistent with thousands of other Egyptian reliefs. However, the Dendera carving continues to captivate because it touches on a genuine, unsolved practical mystery. How did ancient artisans from Egypt to underground cities across the world achieve such precision in perpetual darkness? Whether the answer is simply millions of carefully tended lamps, polished reflectors, or something more subtle we have yet to consider, the question lingers. The Dendera light may not be a blueprint for ancient electricity, but it brilliantly illuminates our own desire to find lost technology in the sacred symbols of the past, a reminder that sometimes the most powerful light is the one that makes us look closer and question what we think we know. The unfinished giant still sleeps in its bed of stone, high on a mountainside across the valley from the fortress of Ollantaytambo. A single pink porphyry monolith lies half-carved from the living rock. Known as the Sleeping Inca, it is a fossilized moment of ambition, a snapshot of a process interrupted, showing exactly how the Inca began to liberate these 50-ton giants from the earth. They would carve the block free on three sides, undercutting its base, leaving only a narrow keystone to hold it in place. That final connection would be broken, and the stone would be ready for its impossible journey. That journey is the heart of the mystery. The fortress walls of Ollantaytambo are built from 6 of these colossal pink stones, each one a masterpiece of polygonal fitting, interlocking with neighbors in a seamless jigsaw puzzle of immense weight. The quarry, however, is not nearby. It is located on a mountainside across the roaring Yorubamba River, and then up a steep, opposing slope. The path from there to the fortress is a logistical nightmare of geography. How did they move these blocks, each weighing as much as a modern tank, across a wide river, and then up the side of a mountain to their final position, nearly 1,000 feet above the valley floor? The conventional explanation involves a symphony of human coordination. The most accepted theory describes the use of earthen ramps, thousands of strong ropes made from leather and plant fibers, and an army of laborers. They might have used log rollers, dragging the stones on wooden sledges across prepared causeways. To cross the river, some researchers propose they temporarily diverted its flow or built a massive, reinforced bridge to bear the incredible weight. Yet, when engineers and archaeologists try to recreate this process, the challenges mount. The slopes are extraordinarily steep. The path is littered with massive boulders. The scale of the earthen ramps needed to reach the high terrace walls would have been a construction project in itself, rivaling the fortress. This gap between theory and practical execution has, as at so many other sites, given rise to more speculative ideas. Local legends and researchers like Brian Forrester speak of the Incas' possible knowledge of acoustic levitation or sound frequency to reduce the weight of the stones, a concept that, while unproven, speaks to the profound difficulty of the task. Expert analysis of the wall itself adds another layer of sophistication. The precision of the joints is, as at Sacsayhuamán, defensive genius. The interlocking shapes make the wall incredibly resilient to seismic activity. But Ollantaytambo was more than a fortress. Its alignment reveals a celestial purpose. Key structures within the complex are oriented so that during the June solstice, the rising sun shines directly through a precisely designed corridor, illuminating a sacred stone. This fusion of astronomy, religion, and military architecture shows a culture thinking on multiple profound levels simultaneously. Further evidence of advanced technique is found in small, square holes cut into the faces of some stones. These are believed to have held metal clamps, likely made of a bronze alloy, which were poured molten into the spaces, locking adjacent blocks together as they cooled and contracted. This technique, seen in other Inca sites, shows a sophisticated understanding of metallurgy and structural reinforcement. Ollantaytambo, therefore, is a site of layered marvels. We see the quarry with its sleeping giant showing us the start. We see the flawless wall showing us the finish, but the journey in between, the monumental effort of moving the mountain, remains shrouded in the mists of the sacred valley. It stands as a powerful testament to what we know the Inca achieved, and a humble reminder of the specific, gritty details of their genius that we have yet to fully comprehend. A valley in Bosnia holds a hill that stares back at you with geometric intent. The Visoko Valley, just northwest of Sarajevo, is home to a series of landforms that have ignited one of the most heated archaeological controversies of the 21st century. Here, businessman and researcher Semir Osmanagic looks at the steep-sided, triangular hill known as Visočica and sees not a natural formation, but the world's oldest and largest pyramid. He has named it the Pyramid of the Sun and claims it is part of a vast, ancient complex built by a lost civilization over 12,000 years ago. If this claim were true, the engineering marvel would be one of staggering scale, potentially dwarfing the Great Pyramid of Giza and constructed from a form of ancient, durable concrete. The debate that has raged for nearly 2 decades is not just about a single hill. It is a fundamental clash over how we read the Earth itself, and a powerful lesson in the human hunger for hidden history. Proponents of the man-made theory point to a collection of intriguing observations. They note the hill's striking geometric symmetry, with 4 triangular faces that appear to align remarkably close to the cardinal points, much like the pyramids of Giza. Ground-penetrating radar scans have suggested the presence of subsurface anomalies and what are described as underground chambers and tunnel networks. Excavations have unearthed large, block-like stones that some claim are ancient concrete, exhibiting a uniformity not typical of natural rock. For the local community and many international volunteers drawn to the site, these findings are electrifying. They speak of a rediscovered legacy, a chance to put Bosnia on the map as the cradle of a forgotten civilization. The ongoing excavations have become a source of local pride and economic activity, a modern quest unfolding in real time. Yet, the overwhelming consensus from the international geological and archaeological community is one of firm, often frustrated, dismissal. Teams of geologists who have examined the site state unequivocally that the hills are natural formations, known as flatirons, created by the entirely normal processes of erosion on layered sedimentary rock. They argue that the apparent symmetry is a common trick of perspective in hilly terrain, and that the so-called concrete blocks are simply natural conglomerate sandstone, a type of sedimentary rock where pebbles are cemented together by nature. The radar anomalies, they contend, are being misinterpreted. This fierce scientific pushback highlights a crucial process in our understanding of the past, the rigorous standard of evidence required to distinguish a human artifact from a work of nature. It is a process designed to filter out confirmation bias, our powerful tendency to interpret ambiguous information in a way that confirms our pre-existing beliefs. When we deeply want to see a pyramid, our minds can effortlessly connect the dots of a triangular hill, some oddly shaped stones, and a radar blip into a coherent, thrilling picture. Science, in contrast, asks for unambiguous proof, like tool marks on quarried stone, artifacts in clear construction layers, or mortar samples that are chemically distinct from natural cementation. The Bosnian pyramid controversy, therefore, transcends a simple argument over a hill. It holds up a mirror to our own ways of seeing. It forces a vital discussion about the standards we use to validate a marvel, and the delicate balance between open-minded exploration and disciplined skepticism. Whether Vysotseka is a natural wonder or a human one, it undeniably proves something profound about us. We are a species irresistibly drawn to find pattern, purpose, and meaning in the landscape, to look at a mountain and wonder if it was meant to be a message. This search for meaning in stone leads us from a modern valley in Europe to a remote Pacific island, where a different kind of pattern was laid out with stones so heavy they seemed to defy the very concept of an ancient toolkit. The most audacious act of creation begins with an act of destruction. In the rock-cut caves of Ellora, India, one structure stands apart, not as a building that was raised, but as a mountain that was revealed. The Kailasa temple is a monument born from subtraction. In the 8th century of the Common Era, under the patronage of the Rashtrakuta king Krishna I, master architects and thousands of laborers confronted a sheer basalt cliff with a vision that defies logic. They did not quarry stones to assemble a temple elsewhere. They took the entire cliff as their raw block and carved a freestanding temple complex directly from it, working from the top of the plateau downward. The scale of removal is almost incomprehensible. Over 200,000 tons of solid rock were painstakingly chiseled away, not in a random excavation, but in a meticulously planned act of revelation. Imagine looking at a solid mountain and deciding to carve an entire cathedral out of it, leaving the cathedral standing in a vast courtyard you have simultaneously carved around it. That is Kailasa. The engineering challenge here was unique and unforgiving. In normal construction, you can add material, correct mistakes, or adjust plans as you go. Here, every strike of the chisel was permanent. There was no undo, no way to glue a piece back on. This required a level of planning so precise it borders on clairvoyance. The master planners had to visualize the entire, intricate final form. The multi-story temple tower, the surrounding pillared galleries, the life-sized elephant sculptures, the freestanding monumental columns, all while seeing only solid stone. They had to calculate the exact volumes to remove, the precise points to stop carving, and the structural integrity of the remaining rock, all in their minds before a single worker made the first cut. The method was a breathtaking inversion of logic. Teams began at the top of the cliff, carving deep, open trenches to define the temple's outer boundaries. As they dug these massive moats of stone downward, the central mass was left untouched, gradually emerging as the temple's main body. Within that central mass, they then began the even finer work, hollowing out grand halls, carving intricate pillars from the solid rock, and sculpting elaborate panels and statues, all while continuing to deepen the surrounding courtyard. It is architecture in reverse, a sculpture where the negative space defines the masterpiece. But this was never just an engineering exercise. Its entire purpose was devotional, a profound act of faith made stone. The temple is a meticulous replica of Mount Kailash, the mythical abode of the god Shiva in the Himalayas, believed to be the axis of the universe. By carving this sacred mountain from a cliff in Maharashtra, the builders were bringing the celestial down to earth, creating a permanent, accessible portal to the divine. Every aspect of the design reinforces this purpose. The central tower, or shikara, rises powerfully, mimicking the snow-clad peak of the mythical mountain. The walls are a tapestry of stone, covered in deeply carved reliefs that depict grand narratives from Hindu epics like the Ramayana and the Mahabharata. Art historians studying these panels note they are not mere decoration. They are a sacred text in stone, designed to educate devotees and surround them with the stories of the gods as they walked through the temple. The scenes are dynamic and expressive, capturing moments of cosmic battle, divine romance, and philosophical discourse, turning the rock into a vibrant, eternal storybook. The precision extends to the most practical details, revealing a mind that thought of everything. The architects engineered an entire rainwater drainage system into their carved mountain. Subtle channels and spouts were integrated into the design, directing monsoon rains away from the delicate sculptures and out of the deep courtyard, preventing erosion and pooling. This attention to hydrological detail ensured the temple's survival for over 13 centuries. Furthermore, Costa is not an isolated wonder. It is the crowning centerpiece of the Ellora cave complex, surrounded by 33 other caves painstakingly excavated from the same cliff line. These include Buddhist monasteries and Jain temples, creating a remarkable landscape of interfaith dialogue carved into stone. This context suggests Costa was part of a larger cosmopolitan hub, a place where different spiritual paths pursued their monumental visions side by side. To stand in the courtyard of Costa is to feel a unique kind of awe. It is not the awe of something immense that was assembled, but of something immense that was deliberately, patiently, and irrevocably set free. It represents the absolute pinnacle of subtractive architecture, a testament to a faith so powerful and a vision so clear that it could command a mountain to become a temple. It asks us a simple, haunting question. What does it take to look at a solid, unyielding obstacle and see, hidden within it, a complete and perfect world waiting to be discovered? The smaller stones hold the deeper secret, while the towering Sarsen circle defines Stonehenge's iconic silhouette. The true engineering odyssey lies within, with the bluestones. These dolerite pillars, each weighing around 4 tons, were not local. They began their existence in the Preseli Hills of West Wales, a journey of over 150 miles across a prehistoric landscape of forests, rivers, and mountains. To move 80 of these stones around 3,000 years before the Common Era was not a casual undertaking. It was an act of profound cultural will, a pilgrimage in stone. The question of how they did it has fueled decades of experimental archaeology, with teams attempting to recreate the journey using only the materials and methods of the Neolithic period. They have tried loading stones onto wooden sledges dragged over log rollers, a method requiring immense coordinated labor and constant attention to the path ahead. Others have tested the theory of river and sea transport, constructing log rafts to float the bluestones along the Welsh coast and up English rivers, a perilous venture demanding expert knowledge of tides and currents. Each experiment reveals the same truth, that every method was brutally difficult, requiring the sustained effort of entire communities over generations. This sheer difficulty forces a more compelling question than how. Why? Why would a society dedicate such staggering resources to bring specific stones from a specific distant mountain? The answer transforms Stonehenge from a mere calendar or monument into a landscape of belief. Recent archaeological work, led by researchers like Mike Parker Pearson, has uncovered a startling connection. In the Preseli Hills, at the exact quarries identified through geological fingerprinting, older monuments were found, ceremonial circles constructed from the same bluestone. It appears the stones themselves and the sacred site they came from held a powerful significance. Pearson's theory suggests the bluestones were not just building material, but revered relics, the physical embodiment of ancestral homeland and spiritual power. Transporting them to Salisbury Plain may have been an act of symbolic unification, bringing the sacred essence of one landscape to consecrate another. This idea is supported by evidence that Stonehenge was a place of pilgrimage for the unwell. Analysis of human remains from around the site shows a disproportionate number of individuals with signs of serious injury or illness, suggesting it was known as a center of healing. The bluestones, perhaps believed to hold curative properties drawn from their unique volcanic origins, could have been the magnet that drew people from across Britain. The shaping of the stones themselves speaks to this reverence. At the Welsh quarries, archaeologists found stone tools and evidence of the precise method, where workers drove wooden wedges into natural fissures, then soaked the wood to make it expand, cleanly splitting the rock along its grain. This careful extraction suggests the stones were valued from the very moment they were chosen. Once at Stonehenge, they were arranged with intention, initially in a double circle, then later rearranged into the familiar horseshoe and oval settings we see today, their positions likely reflecting an evolving understanding of the cosmos and the spirit world. The journey of the bluestones is perhaps the purest expression of a prehistoric engineering marvel. It is not about the scale of a single block, but about the scale of an idea. It reveals a society that measured distance not in miles, but in collective faith, a culture for which the most logical explanation was a spiritual one. They moved mountains, or at least pieces of them, because they believed the stones carried a piece of the divine, and that belief built a monument that has compelled journey and question for 5,000 years. Silence is not the absence of sound, but the presence of a different kind of listening. Within a secluded horseshoe gorge in the Deccan Plateau, an entire world of devotion was patiently carved from the living rock. The Ajanta caves are not a random collection of hollows. They are a symphony in stone, 30 rock-cut sanctuaries created over 800 years, beginning in the 2nd century before the Common Era. This is not a single project, but a sustained conversation across generations, a testament to an unbroken engineering and artistic tradition that adapted and refined its vision for centuries. The marvel lies in the flawless integration of 3 disciplines: architecture, sculpture, and painting, all executed from a single, solid medium with a foresight that feels almost prophetic. The planners did not build upward. They envisioned the complete 3-dimensional interior of a temple or monastery, and then they carved the void around it, working from the ceiling downward to the floor. This ingenious top-down method eliminated the need for any scaffolding, as the workers themselves stood on the accumulating debris of the very stone they were removing. It was a subtractive art of absolute confidence, where every strike of the chisel was a permanent step toward revealing a world already imagined in the dark basalt. The caves serve 2 distinct but harmonious functions, each a marvel of rock-cut engineering. The chaityas are prayer halls designed for congregational worship. Walking into one, you are immediately struck by the sense of soaring space. A central nave leads the eye to a sacred stupa, a symbolic representation of the Buddha at the far end. The ceiling is a perfect, ribbed vault, carved to mimic the wooden architecture of the time, but rendered in eternal stone. The columns lining the nave are not structural in the traditional sense. The mountain itself is the structure. They are rhythmic, artistic elements that guide movement and focus attention, demonstrating that the architects understood the psychological power of space. Flanking these grand halls are the viharas, the monastic living quarters. These are square chambers surrounded by small, cell-like rooms for the monks, each opening onto a central pillared veranda. The verandas themselves are masterpieces of sculptural art, their pillars intricately carved with floral motifs, human figures, and divine beings. This seamless blend of dwelling and decoration created an environment where daily life was immersed in beauty and sacred symbolism. What is perhaps most astonishing is the continuity of vision. Work began under the patronage of the Satavahana dynasty, paused for centuries, and then resumed under the mighty Vakatakas. Yet when new caves were added, they did not break from the old language. They expanded it, refining the styles and deepening the artistic expression. This speaks of a living, guarded tradition, a guild of master sculptors, painters, and engineers who passed their technical blueprints and spiritual purpose down through lineages, ensuring that even after long silence, the song could be resumed on the same note. The engineering extended to harnessing nature itself. The caves were strategically excavated along the curve of the gorge, facing the river below. This orientation was calculated to capture the perfect, diffused daylight. The sun would travel across the opening, illuminating specific paintings and sculptures at different times of day, turning the caves into a dynamic, solar-powered gallery. In the deeper recesses, artisans created elaborate stone screens, filtering the light into soft patterns and casting moving shadows that brought the still stone figures to life. Within these perfectly lit chambers, the walls and ceilings blossom with another layer of genius, the frescoes. These are not mere paintings on a prepared surface. The process was a complex alchemy of engineering and art. First, the rock wall was chiseled to a rough texture. Then, layers of clay mixed with cow dung and rice husks were applied as plaster. This organic undercoat provided both adhesion and insulation, preventing moisture from seeping through the mountain to damage the art. Finally, the artists painted with mineral pigments while the plaster was still damp, a technique known as fresco buono that bonds the color permanently with the wall. The scenes they depicted are narratives of compassion and wisdom, illustrating the Jataka tales, the stories of the Buddha's previous lives. Here, princes, merchants, and animals move through lush landscapes and crowded palaces, their emotions rendered with a graceful, fluid realism that feels vibrantly alive even after 2 millennia. The caves were also designed for sound. The curved vaults of the Chaitya halls are not just visually impressive, they are acoustic chambers. The shape naturally amplifies and clarifies the human voice, carrying the rhythmic cadence of chanting and scripture to every corner of the hall. This was no accident. It was sonic engineering, ensuring that the spoken word, the vehicle of teaching, would resonate with physical and spiritual power, enveloping the community of listeners in a shared vibrational experience. The Ajanta caves, therefore, are far more than a remote monastery. They represent a rock-cut university, a self-contained world where engineering served art, and art served a profound spiritual education. Every carved pillar, every sunlit mural, every acoustically tuned vault was part of a holistic curriculum designed to shape the mind and the soul. It stands as a peerless example of a sustained tradition, proving that the greatest marvels are not always born from sudden, explosive genius, but can emerge with patient, reverent consistency, as a river slowly shapes a canyon, or as generations of hands slowly coax a mountain into a place of timeless learning and light. A frail man in the 1920s moved stones that modern machinery would struggle with. Our journey through these marvels began with a question of scale with the pyramids, and it finds a hauntingly personal echo in the final, modern mystery of Coral Castle. Edward Leedskalnin's solitary work is more than a curiosity. It is a perfect microcosm, a single lifetime compressing all the grand themes of our list into one Florida backyard. Here, in the age of the automobile and the radio, we see the same inexplicable core, massive weight conquered by what appears to be minimal force. Ġgantija claimed he had rediscovered the building secrets of the ancient Egyptians, that he understood the laws of magnetism and weight. He worked alone at night, and he took his precise methods to his resting place. His story mirrors the silence of the Serapeum's boxes and the hidden logistics of Sacsayhuamán. It proves that the enigma of how is not confined to a distant, misty past. It persisted, tangible and taunting, right into our modern historical record. This forces a profound shift in perspective. Perhaps the common thread weaving through Baalbek, Puma, Punku, and a lonely quarry in Florida is not a single, monolithic lost technology, like some forgotten machine or energy source. Instead, it might be something both more human and more elusive, a diverse collection of advanced empirical understandings. These would be deep, tactile knowledges of materials, leverage, acoustics, and celestial cycles, discovered through generations of patient observation and experiment, passed down through guilds or oral traditions, and then vulnerable to being scattered, suppressed, or simply forgotten when a culture falls or a way of life ends. Ġgantija, in his obsessive solitude, may have stumbled upon one such fragment, a piece of a much larger puzzle of physics that our mainstream science has overlooked. So what do these 30 marvels ultimately represent? Are they peaks of human potential, showing us that ingenuity can flare with or without complex tools, that a driven mind can achieve the seemingly impossible? Or are they clues, stubborn fragments pointing to a broader, forgotten past where such understandings were more widespread? The truth likely lies in the tension between both ideas. They show the breathtaking heights of what dedicated human focus can accomplish, while also whispering that our timeline of progress may be missing entire shelves of the library. Coral Castle, as our final marvel, refuses closure. It ties our journey together not with an answer, but with a deeper, richer question. It leaves us wondering if the greatest mystery is not the stone itself, but the quiet space between what we know can be done and what we see was done. That space is where curiosity lives, and it is the very essence of the wonder that has drawn us through these ancient landscapes, a reminder that some secrets are not meant to be solved, but to be pondered, keeping the door to the past forever, tantalizingly ajar. From the global pyramids to the solitary obsession of Coral Castle, these 30 marvels form a mosaic of human achievement that stubbornly resists simple explanation. They are not a collection of isolated oddities, but points on a map of a different kind of history, one that is not a straight line of progress but a complex tapestry. In this tapestry, threads of profound knowledge appear, shine brilliantly, and then sometimes vanish for centuries, only to be glimpsed again in a different time and place. The most important lesson woven through this entire journey is not about aliens or lost super-civilizations, but about humility. It is the quiet acknowledgement that our ancestors, across the globe and across millennia, possessed forms of ingenuity and understanding that we are still striving to fully comprehend. Their genius took many forms. Sometimes it was an advanced empirical science, a deep, tactile knowledge of materials like the self-healing Roman concrete or the rust-proof iron of Delhi. Other times it was a sophisticated grasp of physics and acoustics, perhaps used to move mountains of stone at Sacsayhuamán or to shape the perfect spheres of Costa Rica. Often it was the sheer, breathtaking power of communal will and coordinated vision, the kind that could carve a temple from a mountaintop at Colossal or walk statues across an island. They manipulated their world with a patient, observant intelligence that speaks to a different relationship with nature, one of collaboration rather than conquest. This exploration, then, is not an end but an invitation. it is a call to keep questioning, to keep researching, and most importantly, to keep looking at the past not as a solved puzzle, but with a sense of genuine wonder. The next time you see an ancient monument, do not just see an old pile of rocks. See a question mark in stone. See a message from a human mind not so different from your own, who found a way to make the impossible tangible. If this journey through ancient mysteries has captivated you, there are countless more threads in the tapestry to follow. Subscribe for more deep dives into history's greatest puzzles. And we would love to hear from you. Share your thoughts in the comments below on which of these marvels you believe defies logical explanation the most. The past is not a dead and silent place. It is full of whispers waiting for anyone willing to listen closely.